Okay, so I'm going to start back with cathodic protection. And this is going to affect what? It's going to affect your steel single wall buried tanks. So by December 22nd, 98, owners of motor vehicle fuel tanks constructed of steel were required to retrofit these tanks with either secondary containment or upgrade the tank. And these upgrades were required to prevent the corrosion of a steel single wall tank. So these are going to be the buried tanks that are in direct contact with backfill, soil, pea gravel, what have you. Okay, so what's corrosion? We hear the term all the time, but what exactly does it mean? This is a process of metal, in this case steel, releasing energy to reform its natural ore. And it's a normal occurrence for basically all metal, all steel products. And here's a small diagram showing this. You start with your iron oxide, of course. It goes through the refining process and the milling, and you get your steel tank, you get your steel beam, your steel hulls, whatever. And then corrosion is the steel material trying to get back to its original iron oxide. So this is not a good thing if you have a steel tank underground holding your hazardous substance. This is what we want to see. So here's just an example of what corroded steel might look like. Okay, so here are some of your options. Like I mentioned, you had the option of retrofitting your tank with secondary containment, which basically means you could replace the original parts with secondary containment. And unless you want to do a complete new install, that's not a very good option for most people. But your other options, also known as your upgrade options, is cathodic protection plus something else. So no matter what scenario you choose, you're going to need cathodic protection and either an interior lining for your single wall steel tank or a bladder system. So I'll go into some detail about interior tank lining. Like I mentioned, it can be used to satisfy part of the upgrade requirements. And keep in mind, if a steel tank is lined for the purpose of satisfying that section, then it shall be inspected by a coatings expert or special inspector within 10 years of lining and every 5 years thereafter. And those definitions, special inspector can be found in Health and Safety Code, so everybody knows what that is exactly. And coatings expert can be defined in Title 23. Okay, and in San Diego County, we did require a permit during that 10-year inspection just because of what it took to get involved with the tank. There's tank entry. So we had a permit requirement, and we had our emergency response team have oversight at the time of tank entry, just to be involved. The thing to keep in mind is if you do have lining, it's not considered secondary containment. So it's not an actual retrofit. It's simply used for the corrosion protection. Okay, and here's some pictures showing the interior lining process. It's very involved. It requires tank entry. I've never seen it done, but we have about 7 or 8 tanks in San Diego County that have this lining. Are you guys familiar with this process, or no? Okay. There's not that many. We have a pretty big county, and there's, like I said, only 7 or 8. And then when we talk about bladder systems, I've never seen one of those. So if anyone has any insight on bladder systems, you can certainly share that with us. So this is what I imagine it might look like. I found this picture, but the idea is this flexible or rigid material will provide primary containment, and it will be inserted within the secondary, what will now become the outside shell, the steel shell. And it also includes an interstitial monitoring system. And this also is defined in Title 23. And like I said, we have minimal experience with this type of upgrade. So if anyone has anything to add, just, shout out. So like I said, cathodic protection needed to be combined with interior lining or the bladder system. And some of the common methods include sacrificial anodes, and impressed current system. And I also have here fiberglass clad steel tank, and obviously this is for a new install. You're not going to be able to retrofit or upgrade an existing steel tank with a fiberglass coating. So you're going to install this right from the get-go. Okay, so we're going to go into detail about the sacrificial anodes and the impressed current system. But before we get there, I just want to show you a picture of what the fiberglass clad steel tank would look like. So it has the familiar shape of a steel tank, no ribs as you would find for fiberglass tanks, but it has that thin coating of fiberglass. So that's going to protect everything from the backfill, being in contact with that backfill or soil. Okay, sacrificial anodes, it's a more active and easily corroded metal. A common example would be aluminum. So the idea is that it will give up their electrons more readily than steel. Okay, so they're going to be attached to the tank. They're also going to be in surrounding the tank or within the tank farm in the pea gravel. And if you look on this picture there on the left, you have the energy potential. So you have steel right there in the middle. So that basically shows that magnesium, zinc, for example, they're going to give off their electrons more easily than steel. So if something's going to be corroded in the area, the sacrificial anodes are going to be the ones losing electrons rather than the steel. However, if you put steel and gold together, steel will become, the anode because it will give off its electrons more easily than a more stable metal such as gold. Okay, and here's just a system, how it might look within the ground. You have your steel tank, which is also known as the cathode, and it's being surrounded by the sacrificial anodes of whatever metal that's been designated for the system. Okay. And then the other option is the impressed current system, and this is often used for a larger tank farm because it's stronger and it can reach more area. And it uses ordinary electricity, and however it's converted through a DC current with the help of a rectifier. The electrical current is sent from the rectifier to anodes in the soil, which surround the tanks, and it distributes a protective current over the tanks. So this allows the steel surface to shift its potential in a more negative way to prevent the corrosion. And here's just an example of how an impressed current system might look in the ground. Up at the top you have your rectifier. This is not the best picture, but you get the idea, where you have you have your tanks here, and it's surrounded by these anodes, and it's also hooked in with the rectifier, which is giving out that current, which is blanketing the tanks and providing that negative potential. Okay, just a few notes about impressed current systems. They need to be tested within 6 months of installation and every 3 years after by a cathodic protection tester. And once again, this term is defined in Health Chapter 6.7. And the rectifier must also be tested every 60 days by owner or operator, and they need to keep a log of that. I've only seen it one time, but they basically are looking for the meter to stay within a red point, a red section that's designated. So it doesn't require a whole lot of special training, but they still need to log the different voltages or amperes when they do the inspection every 60 days. All right, just a quick pop quiz on cathodic protection before we move on. True or false? An interior line tank is considered to be secondarily contained. False, right? So it's strictly corrosion protection. An upgraded steel tank needs interior lining or a bladder system in conjunction with what? That's right. You guys are listening. Love it. Okay, true or false? Oh, whoops. Cathodic protection. All right, spill containment. I'm going to hand it over to Zoraida, and she's going to tell us a little bit about spill containment, overfill prevention, and under dispenser containment.
Good morning, everybody. So Cecilia, Steven, and I, we all are talking about USTs today. But USTs, what we always think about is just the tanks, right? The underground storage tank and piping, but there's some other components also related to a UST system. And I'll be talking about a few of those. I'll be talking about spill containment, under-dispenser containment, and overfill prevention. So my first section is spill containment. Do we know what that is? And did I turn it off? Next. Okay. What is a spill containment? Spill containment, it's designed, the purpose of a spill containment is to hold liquid when there's a overfill, a release when the delivery person is filling the tank. If there's any leak, it should be caught in this containment. And in the photo, we can see this is the product riser spill bucket. This is when the person is delivering fuel or adding any content into the tank. Sorry, he connects or he drops in any substance into the tank through this point. This one is the vaporizer spill bucket. In fuel tanks, for gasoline, for example, they have this one when they're adding the fuel in here, and they have this one for the vapor. And this is not working again. Okay. For example, the diesel tanks, they don't have the vapor bucket, okay? Now per law, we are only required to test the product riser spill bucket. In San Diego County, we only test that one, but I know that some other counties do test both buckets. It's not required, it's just a recommendation, so it's up to their local agency if both want to be tested. Next one. So what is it? Can I just put any bucket there? No, it has to meet certain requirements. It has to hold a minimum of 5 gallons. It has to be resistant to corrosion, and it has to have a functioning drain valve, or there should be a manual pump on site available too. And so we install the bucket, and now what? Well, we have to make sure that it works. For this, we have to run a test every year. Well, not we, it has to be tested every year. Now, the owners and operators are the ones always responsible for doing the testing. Now, the spill buckets in opposite to the rest of the equipment, who a technician has to be certified to do test. For spill buckets, it can be anyone. It can be the owner of the UST who can do the test. But most of the time, we see the technicians doing the test during the annual testing. So they just have all components tested at the same time. And how do we test? How do those spill buckets get tested? Well, there's a variety of methods. We have the vacuum test, and I've never seen that one. Have you ever seen one? They actually have to seal the bucket. They put a clear lid on it. They have to put vacuum on it, and then they have to read an initial, like the pressure at the very beginning of the test, and then go back later and see if it dropped any pressure. And then they can consider that a fail or a pass, depending on if it lost any vacuum. And now with a clear lid on top of the bucket, they can also add soap around it and see if there's any leak going through a certain point. They do it like when we do a soap test on the piping. So it has good points. The vacuum test, you can detect where the leak is going on, and you do not generate any hazardous waste, but it's hard to get a good seal on a bucket. The other method is the hydrostatic test, and this one you have two options. You can either do a leak test. This would be a visual hydrostatic test, and I think that's the most common one. For that, you just add water to the spill bucket, and you have to measure it. You can do it with a tape measure. You can visually observe if there's any leaks around the bucket, and you just have to go an hour later and see if the level of the water dropped. And again, if it dropped, it failed. If it's stable, then it's passing. The other option is the accelerated precision test. For this, the technicians this one has to be done by technicians, because for this one you need instruments. And most of the owners are not certified to operate any instruments to do testing. So this would be, for example, a test that they use the Incon or an MTS equipment. And those are the equipments that we mostly see during secondary containment tests. And there's a guidance for testing spill buckets. It's number 166, and it will give you all the details on how to test through any of these methods. So, and how do they tell us that they tested the spill buckets? Well, they have to report this form. This is our form from San Diego County. It's similar to the secondary containment. It lists what components were tested or what tank. This spill bucket is for tank number 1, number 2. And then they have to provide us the initial reading of the level of the liquid, then the final reading, and at the end, pass or fail. Now, if it passes, good. They're good for 1 year. They can do the test again in a year later. If it fails, they have to either repair it or replace it. And they have 30 days to do either or. Now, for testing spill buckets, they have to give us a 48-hour notification. And we do not have to be there all the time. We in San Diego County, we're always there because we do this testing at the same time as the annual monitoring certification and the inspection. And why do we have to test the spill buckets now? Well, we have to test them because the idea of a bucket is to contain any leak that occurred during the filling of the tank. We have to test it to make sure that it's actually going to hold any substance that got released and that it's not going into the secondary containment or the sump. In this picture, obviously, the spill bucket is failing. And this is an example of a spill bucket in a secondary containment area or in a sump. And for this, we can either use the hydrostatic visual test or the one with instruments. Now, the one with instruments, okay, this spill bucket is in a secondary containment area. We have some spill containments that are direct buried. And for those, we do not take any visual hydrostatic test because we cannot observe around the bucket. For those direct buried spill containments, we require the hydrostatic test with instruments. That was fast. Okay. Any questions for me before I ask you guys questions? No? Okay. How often do we have to test the spill buckets? Every year. Do we have to be present? No. Are vaporizer spill buckets required to be tested? It depends. It depends on the local agency. So it's per the state regulation, those are not required to be tested. They're recommended to be tested, but then check with your local agency to see if maybe they require it. Remember, local agencies can be more stringent than the state. So no, they do not have to be tested. The next topic is overfill prevention. Now, the spill containment is to catch any leak that occurred, right? The overfill, we're doing something prior to any leak. We don't want that substance to get released. Okay, so the overfill prevention improves the ability of a UST system to prevent the release of a hazardous substance when fuel is added to a UST. It has to be installed at the very beginning when the tank is newly installed for new USTs, and those that were existing USTs, ATGs were required to be retrofitted by December 22nd, 1998. So by now, all tanks that are being put in place, they already have the overfill prevention equipment. And there's 4 options. The state, they always give us options, and there's always one that is more common or one that we prefer. There's one that we have never heard of. So here we have the first one. That one is That one relies on the use of an ATG and a ball float, and that there's some certain characteristics. I'm just going to mention them pretty quick, and then I'm going to go through the next slides covering each one of them. The first one is ATGs or flapper bulb. The second one is, no, not flapper bulb, I'm sorry, ball float. The second one is ball float and ATG. The third and fourth, those talk about the flapper. So let me go to number one. So for this one works, the overfill, when the tank is being filled by 90% of the capacity. It should trigger an audible and visual alarm, or it should restrict any product getting into the tank when it reaches 90% of capacity. And I have the definitions there. What is a ball float? Or that's an extractor fitting inside an access port. It's usually by the riser. And I'm going to show you a picture on the next slide. And the audible and visual alarm, that one is set to deliver. That one, as soon as the fuel reaches the 90%, it alerts the driver that the fuel has already reached the 90% and he cannot add any more fuel. The ATG is audible and visual because it's connected to a buzzer. It has to be visible, and a light bulb. It has to be visible by the driver, and audible, obviously. And again, those are also tested every year. If they fail, they have to replace them. What I found funny is when we test the ATGs and the light bulb fails, they just need to replace the light bulb, right? Most of the time, and we just tell them, the overfill visual alarm is not working. But when we can just say, just replace the light bulb. But okay. Some people, they still ask you, how do I repair that? And work any light bulb? Do I have to get a specific one? Okay, so that picture on your left shows an ATG. Let me see if this works now. This is a float. It has two floats. This one is on the bottom, and this one gives you the level of liquid, water that got into the tank. This one is the second float. This one gives you the actual level of the fuel in the tank. So when the technicians are testing this, they need to make sure that this one is at the bottom, and then they slowly raise the second float to pretend the volume is getting higher here. And it died again. So that flow has to be set at 90%, and then we will be able to see and hear the alarms. And then we have to go inside and make sure that the monitoring panel is giving us an overfill. Sometimes it would give us a high product that's set at 95%. So we have to test that again because we want to see that 90%. We have to make sure that the alarm went off at 90%, not at 95%. And the photo within the square, that one is the audible and visual. That's the light bulb. Let's say that the technician started testing and you were not ready, or he turned it off and you didn't see the light. You can just go to that box on the right, and there's a button, a test button. So you can just press it and see if it's gonna go off both either the light or the buzzer. Excuse me. Now the picture on the right, that's a ball float. Now this one, it's in the bend riser. When the fuel is coming up, when the level is going higher, this ball starts going up, and then it's gonna block this exit of the bend, right? By blocking it, it's gonna put some pressure on the bend inside the tank that is gonna restrict any fuel going into the tank. So for the first option of the overfill prevention, you could either have the one on the left or the one on the right. Now for this one, you needed both the ball float and the ATG. But in this case, it has to be set at 95%, not at 90%. And the equipment is the same one, the same ATG and ball float. The other options are the flapper bulbs. The option number 3, that one requires the flapper bulb the flapper bulb has to close or to prohibit any liquid going into the tank when it reaches 95% of its capacity. And number 4, it doesn't give us a percentage, but it also relies on the flapper bulb. And I never seen number 4. Have you ever seen any device with that? I've never seen a flapper bulb without the 95%. Now that's a photo of the ATG. It's actually put in the probe, in the product probe. And this one, when it similar to the wall flow, when the fuel is coming up, the volume of the fuel is going up. This is gonna start racing, and then this flapper is gonna block here. This is gonna, that float is gonna come up, and the bulb is gonna go down, and it's gonna block any product going into the tank. Now, if there's a flapper, it has to be working. If there's a wooden stick inside the probe, it's not gonna work because it's gonna block the flapper from actually doing its function, which is blocking the fuel going into the tank, right? So if even when we do not test the flapper bulbs, just make sure that you take a look at it, and you can see that it's gonna work. If you see anything like this, it's the overfill prevention system that they have is not working. That's a violation that they need to correct it. And that's a violation that can be corrected right away. That's wrong. Now the ATGs have to be tested annually. The overfills, the ATGs, those do not have to be tested. But if they're in their UST monitoring plan, they said that they relied on the ATGs and in the flappers as their overfill prevention. We have to test the ATGs even if they have the flappers. At least that's the way that we do it in San Diego. And this is a layout of the UST system, and you should have a copy on the handouts that you got on the back page. This is the location where the ball float should be installed. This is the vent riser. The second one, it's the where the flapper is. That's the product fill probe. Then the third circle that we can see, the oval, that's the ATG. Yes. Yes. The first option give us the option to use either the ATG or the ball float. Yes, at 90%. And the other one at 95, you have to be using both. Any other question? Okay.
Somebody? Did you ever find anybody for having the delivery stick in the flapper blocking the flapper?
That's what the photo was.
But have you ever find anybody for it?
Doing it?
Yeah.
Or find the person? No. We don't find the person. We wrote a violation for the facility and just corrected right away, but we don't issue fines unless, let's say, they wouldn't hear or do anything that we tell them to do. Then we do enforcement. We do not issue fines. The next component that we check is under dispenser containments. Now that's a drawing of a dispenser. Now, do we check the dispenser as part of the UST system? No, we only check the part that is below ground, right? The underground, the under dispenser containment. That's the area that is circled in the red circle. Okay, what does this area monitors? It actually, that section is there to hold any leak that occurred in the single wall piping in this area. Let's say a new system now, it has to be double wall piping, and it's coming here. That double wall is not gonna end here, and then you have this single wall piping passing through there should be a shear bulb here, but this one is coming all the way up there. That single wall piping has to be secondarily contained. That's why we have the the under dispenser containment there. Now, do we test those? Well, they have to be tested as well every year. Now, we cannot do a visual hydrostatic test. Why? Because we cannot observe around the under dispenser containment, right? So we have to do the one with the instruments. Now, if it's with instruments, it has to be done by the technician. And we have to make sure that whoever is doing the testing, he's certified to do test. This photo, where's the floats? I don't see them. Okay. But that one was that was during an installation, so you can actually see the piping on that area and all the pea gravel here. So when it's a new install, you can actually do the visual hydrostatic test, and then the later ones they have to be tested with the instrumentation. And also for under dispenser containments, they have to give us a 48-hour notification. They have to send us results. Now, have UDCs always been there? No. They were required at time of installation for new UST systems that went into place on January 1st, 2000. Then for all systems that were installed after July 1st, 1987, they were required to have UDCs by July 1st, 2001. And by December 31st, 2003, for systems yes, for all the rest of the sites. So by now, all facilities that have a UST system, they should have a UST, a UDC. Okay, now that UDC is gonna hold any leak that it's coming from the single wall piping inside the UDC, right? How are we gonna make sure that we get any information or that we notice that there's a leak? Okay, there's a monitoring. We can have a sensor there. There's 3 options. The first one would be an electronic sensor, and I have photos in the next slides. Or we can have a float and chain, or we can have the standalone sensors. And they work in different ways, but they both have the same function. If there's any leak in the UDC, we should not be able to get any fuel being pumped, or we should not be able to see any fuel in the piping in the dispenser, right? The electronic sensors, those are connected to the monitoring panel inside the facility, and those are actually gonna shut down the turbines if there's any leak detected. The float and chains, those are not electronic. For those, if there's any leak, that float is gonna trigger the shear bulb, and it's gonna restrict any flow of fuel from the tank to the dispenser. Now the standalone sensor, that one is just gonna cut power to the dispenser. So in any instance, you're not gonna be able to pump any fuel from the tank. And this is a photo of on the left we have the sensors that Steve was mentioning before, the 208 sensors. That's a Bitterroot sensor, is the most common one, but we can have discriminating sensors, or this one. This one just tells us there's liquid. It can be either fuel or water. There's also discriminating ones that will tell us if there's fuel or water, how much is it. It doesn't matter. If they're gonna be using an electronic sensor, we just need to know that it's gonna detect any leak and that it's gonna shut down the turbine. The picture on the right shows a float and chain. That's the float. So when there's liquid coming in here, and it can be either fuel or rainwater that got into the UDC, this float is gonna pop up, and this is the shear bulb. So this is gonna unsecure this section here, and that is what is gonna restrict the flow of the fuel into the dispenser. And this is the standalone sensor. The picture on the top left, it shows a screen that's the card reader on the dispenser. So it should be normally it's on, right? When you go to that to get fuel, that's the place where you're gonna swipe your card and type in your PIN number. The picture on the right top, that one shows the sensor. That's one of the standalone sensors before being tested, and the picture on the bottom right shows that sensor dipped in water. That should trigger, that should cut the power to the dispenser. That's what we can see on the screen on the bottom left. Now the power went off and we should not be able to pump any fuel.